What's up everyone, welcome back to another video, and in this one we're going to continue with using PyQtGraph and OpenGL to do more 3D graphics and 3D rendering. So the example you see here is a 3D mesh with some surface variation and also a flyover effect, like a plane flying over a terrain. So in this video I'm going to show you how to set this up, and this is going to be the base for our audio visualizer. And in the next video we'll continue with that, but for now we're just going to go through setting up this example here. So let's get started. To begin, I got the idea for this example from another YouTube channel called The Coding Train, and in this video you can see they make a 3D mesh surface with some roughness using Perlin Noise, and they also add the flyover effect. This example is using Java and something called processing, but we can still use the concepts and apply them to Python. So I'll walk you through how we do that now. So let's begin. I've got a blank Python file, and what I'll do is start with the imports. So what we're going to need is NumPy, PyQtGraph.qt, we're going to need QtCore and QtGUI. We're also going to import PyQtGraph.OpenGL as GL. And if you don't have this, what you can do is just run, you'll just run this command, conda install -c anaconda PyOpenGL. Run that if you don't already have it, and then we're going to import sys like always, and then for the Perlin Noise, I found this library called OpenSimplex. So from OpenSimplex, we're going to import OpenSimplex. And for that, it's just pip install OpenSimplex. Do those imports and run those commands if you're missing the libraries. Cool. So let's begin with the class. So what I did was I called this class terrain, and start with the init method. So like always, init and then self. And what we're going to do is we're going to build the window or set up the window. So let me go ahead and copy this stuff over here. So we're doing qtgui.queapplication, and we're passing it sys.argv, which is pretty common. So that's going to be our app. Then we're going to create a GL view widget, which is basically our window. So the W stands for window. We're going to set our geometry. So I'm making it 1920 by 1080. Then we're going to show it. And then we're going to give it a title. So let's call it something else. Let's call it terrain. Cool. And then I'm just going to position the camera. So we're going to back it up a little bit and add a little bit of elevation so it positions it nicely to show that flyover effect. Alright, so let's add the if name equals main part, and we're just going to create, we'll do t equals terrain, and let's just run that, see what we get. We should just get a window. Yeah, we get a window that pops up but then fails. So next thing we need to do is create our start method. So this is a pretty common statement that we're going to need to put somewhere. So the start method, you can see here, this is just some common code that we're going to need to get the window started. So what I'll do here is then call t.start. So now when I run this, we get the blank window. So good, we've got that. Let's continue. Next thing I want to do is add a grid. And the reason why I'm doing this is to help visualize how we're going to set up our vertexes and faces. So the way we add a grid is we're just going to call it grid, and it's going to be gl.gl grid item. Then we're going to specify the scale, and then we're going to add it to our window. So if I run this, you can see here that we've got this grid on the floor of our 3D area. So what we're going to do with this is we're going to add vertices at each corner. And actually we're going to do, these boxes are basically 2x2s. So it's minus 20 to plus 20 is the scale. And what we're going to do is we're going to add vertices every point. Like say, if I just zoom in from here to here, there's going to be 1, 2, 3 points. So the way it's going to work is, like I said, there'll be a vertex here, vertex here, vertex here, 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 and here. So all the corners, and then the midpoints, and then one in the middle. Then, so each one of those little squares, there's going to be 2 faces. So you can think of it as 2 triangles, and there's going to be a face, a triangle face on each of those surfaces. So 2 triangle faces per box. So we need to set up the vertices, and we need to set up the faces, and we're also going to specify the color of each face. So now let me walk you through that part. So the way I'm going to do this is first I'm going to define a few variables and arrays. So the first variable, we're going to call it self.step. Actually, I'm going to call it nStep. And this is just going to be equal to 1. So this is the distance between each vertice. Then we're going to do self.yPoints, and this is going to be equal to range, and then it's going to go from minus 20 to positive 22, and it's going to have, the step size is going to be self.nSteps. And then we're basically going to do the same thing for the x points. So this will be an x, and this is all the same. This is what we're going to loop over to create our vertices. So bring that up a bit. And then the next thing we're going to do is this thing called nFaces. So this is going to be the number of faces. So that's going to just be the length of self.yPoints. It doesn't matter which one since they have the same length, but this is going to be what we use to loop over the faces with. So that's the nFaces. Next thing we're going to do is set up our vertices. So we're going to call it verts, and this is going to be a NumPy array, and we're going to make this in a list comprehension. So it might get a little complex, but I think this is the best way to do it time-wise. So each point is going to be a list. So we're going to have X, Y, and Z, the location on the grid, and then its height, Z. So each point is going to be a list, and then because it's going to get long, I'm going to put it on a new line. So it's going to be X, Y, and then the height, for now let's just do 0 to keep it simple. And yeah, let's keep it this way for now. So that's our list, and that's going to be for n, comma, x in enumerate. So we're going to enumerate self.x points, x points, come on. And then for m, comma, y in enumerate self.y points. And then finally, I'm just going to specify the D type, and we're going to use np.float32. Cool. So now what this is doing is each loop iteration, we're creating a list with 3 values. So there's going to be like list, list, list. And we're going to go through all the X and Y points. It's going to be like its own little list. And then that's going to go into a NumPy array. So if it's a little confusing, why don't I go ahead and print it out just so you can see it. So in order to shrink this, let's just make this, let's make this minus 16 and minus 16. And then for I in verts, let's just print I. So I'll run this. The window didn't work. What did I do wrong? nSteps. Okay. Try again. Alright, so just to show you, so you can see here we're going just over all the points, minus 20, 20, and all the way up to these points here. So it's just a big array, and each point in the array is a list. So hopefully that helps. Let me go back to 22. Cool. So we've got our vertices set up, and we're going to change the height to be the noise value. So next what I want to do is we need to create our faces. Yeah, let's do that first. So we'll create an empty list called faces. And this one, we're not going to be able to do a list comprehension because that's just going to be too much to put in there. So what I'll do, it's going to be a similar setup, but for m in range self dot and faces -1, we're going to define something called the y offset. So I'm going to call it y off. It's going to be m times self dot and faces. Cool. So you'll see why we need this offset in a second. And then we need to do our other loop. So for n in range self dot and faces also -1. Now what we're going to do is we're going to add our faces to our faces list. So the way we do that is going to be faces dot append. So the first one, let me pull up the image first so we can see this. So if I just kind of zoom in on one square, so our faces, the way you specify them is they're going to be triangles. So we're going to create a list of those 3 points, and that's going to represent a face. So for example, if like we had these 4 points here, if it was 1, 2, 3, 4, and we wanted to create this triangle, it would be 1, 2, 3, and then this one here would be 2, 3, 4. Or in Python, since we started 0, it would be 0, 1, 2 for the first face, and then 1, 2, 3 for the second one. Yeah, so if that's a little confusing, let me show you how I set it up, or how I did it. So what we're going to do is the first one is going to be a list. So it's going to be n plus our y offset. Then it's going to also be y offset plus n plus the self dot n faces. And then again, y offset plus n plus self dot n faces plus 1. So this might look a little bit confusing, but the reason why we need to add this thing here is because when we create our vertices, let me pull up the thing again. We're going like, our vertices go like 1 or 0, 1, 2, 3, 4, all the way to the end of the row, and then they start back here. But we want to create our face that's like this one, this one, this one. So in order to do that, this next point is actually like 20 points down the list. So that's why we have to add that self.end faces to it. And then the offset, that y offset, is every time we reset the end loop, we need to shift down the whole row. So that's like a, that's a big jump. Cool, so that's why that one's set up there. And then to create the next one, it's basically the same thing. So I'm just gonna copy and paste to save time. And that needs to be that. Cool, so that is that. And then finally, we just need to make this a NumPy array. So I'm just gonna rename faces to add it into a NumPy array. Cool. And then finally, to make this a mesh surface, what we need to do is, again, I'm just going to copy and paste this to save time, but the object is, I'm just going to call mesh1 or m1. So it's going to be GL mesh item. So we're going to specify the vertexes, which is our verts. We specify the faces, which is faces. Since I don't have color, we'll leave that out. And then we can just do smooth equals false and draw edges equals true. Cool. So finally, we just need to add this thing to our window W. So it's going to be, we're going to set some view options called additive, and then we're going to add M1 to our W window. So now if I run this, oops. Oh yeah, so since I didn't specify the colors, it just made them all white. So let's add the colors in there. So for the colors, we need to add another list called colors, and let's just do colors dot append, and then for now let's just make them all and the translucency will make it also 0. So this is just going to be nothing. We're not going to see any colors. And then finally we'll do the same thing. Colors equals np.array colors. Alright, so now when we run this, oh, it did give it some color. Anyway, that's weird. But so you can see here that we've got our mesh grid set up. So you can see all the little faces here. So each like square becomes 2 triangle faces. Not sure where that color is coming from, but anyways, that's what we've got here. I think because, oops, I need to add 2 of these. There we go. So yeah, I didn't have enough colors in the list, and it just decided to make it some pinkish thing. So anyways, this is our completely flat mesh surface with everything connected and specified and set up correctly. And this actually took a while to get set up. It was a bit confusing, but this is the correct way to do it. And finally, just to show you that they're all connected, what I'll do is we'll make this thing instead of 0, let's do np.random.normal, and we'll just do 1. So now you can see we've got this, like, now the height is just some random noise thing. So it's just varying randomly. And like, this is a good start, but the idea is to make it look a little more natural, like a normal terrain, and that's where the simplex library that we imported comes in. It gives us what's called Perlin Noise, and what that is a little bit smoother, so it's more smoothly varying, where each consecutive point differs slightly from the previous one. So here it's just completely random, and you can have any height, so it's just very chaotic. But the Perlin Noise will give us a more natural look. So let's do that now. So in order to add the noise, first thing we need to do is create an OpenSimplex object. So I'm just gonna come down here. We're gonna call it self.tmp, and it's gonna be equal to capital O OpenSimplex. All right, so that's our object. So instead of the random noise, we're going to put this here, and it's going to be self.tmp.noise2d. So all we need to do is give it some x value and some y value. So the way I set up the x value is, since we're looping over, I'm going to do n divided by, and then I did 5. You can play with these parameters to make it smoother or rougher, however you like. And then for here, we'll do m divided by 5. Cool, let's try that and see what that looks like. All right, so you can see this is a lot more smoothly varying. It's more like rolling hills instead of like sharp dagger peaks and things like that. So you can, like I said, if you wanted to make it rougher, I think you can lower these, and yeah, so you can see here's a little bit rougher terrain, more varying quickly. So I went with 5. I think 5 looked good. And then you can also add a multiplier out front here. So if you wanted to make things a little bit larger, so I did 1.5, and this gives us a little bit higher peaks. But yeah, so that's how we set up our terrain. So the next thing we want to do is create a function that's creating this thing, this terrain, and then we're going to link it to our QTimer. So that way it's going to keep calling that thing, and then we're also going to add the variation to make it look like the flyover. So let's do that now. Now what I'm going to do is create a method called animation. So I'm going to copy and paste it from another example since it's basically the same thing as what we used with our PyQtGraph audio visualizer and then that multiple sine wave file that I showed you. But the animation method, we're creating this thing called timer, and it's a QTimer. And what we do is we connect it to a method which is going to be called in a loop. We specify the loop interval, so the time in milliseconds between each call to that method, and then we call update and start. So if I were to just do this and change start to animation, we should get the same thing. Yes, we didn't break anything. All right, so now what we want to do is create the update method. So I'll do that. We'll do that right here. So update self. And now I'm just going to copy and paste all the same stuff from this one here up until the colors. Oops. So we're keeping faces and verts. Just making sure. Yeah. So cool. So we'll put all that here. So we've got verts, and then what we're gonna do is our object was remember it was self.m1, and now what we're gonna do is it's set mesh data. So the way we do that is we're gonna specify the vertexes. Those are just gonna be verts. The faces again are gonna be faces. The face colors is going to be colors, and that should do it. So just to give it some color, I'm going to copy and paste some stuff from my other one. So let's do this, and also this needs to be faces. And we'll make the alpha a little bit more visible. So I went like this just to give it some variation. So let's see if this works. And it's not, okay, it's not calling it because, yeah, we need to uncheck this stuff. So let me uncomment that out. So now you can see even though it's not changing, we are regenerating this terrain consistently. So we keep regenerating the same thing over and over again. So you can see the colors, and yeah, so it looks pretty cool with the colors. You can play around with that and make it look more natural if you like, but this is what I'm going for here. So the final step is to add the flyover effect. So the way I did that was up here, I created an offset. So we're just going to do self.offset. We're going to start it at 0, and then where we can place it, you can think of this function here, this noise2d. So you just give it your X and Y location and it gives you the value. So what we're going to do is just shift the X and Y positions each time so that it looks like the terrain is moving in one direction. So it does the job. It gives us the effect. So we're just going to plus the offset for Y and X. And then finally, once we're done with everything, we're just going to do self. So we just need to update the value. So we're going to go in the minus direction to make it look like we're flying forward. So it looks like the terrain is moving towards us. So I'm going to go with, we'll go 0.15. Again, this is another parameter you can play with. And let's run this. Cool. So here you can see we're basically getting the effect. So one thing, I'm gonna get rid of that mesh grid thing on the bottom, that like base grid. You can't really see it anymore, but it just adds more lines that we don't need. So let's do that just real quick. Get rid of this. And I think I want to make this height a little bit higher, and then maybe go slightly faster. So if you increase this, it makes the look like you're flying faster because it's offsetting it more each frame. Cool. So I think that's it. This is what I was going for. Probably I'll tweak with some of the parameters to make it look different, but you can see here we're getting the same effect. We're getting a nice mesh terrain that we're flying over. So in the next video, what I want to do is make the level of the mesh represent the spectrum of the sound at that time. So I want like the spectrum to appear and then it to sort of fly at you, and then you see it changing. So like instead of this mountainous terrain, I want it to be like the frequency spectrum, so the highs and the lows and the amplitudes of the sound that we're listening to, like a song or just straight from the microphone. So that's gonna be the next step. Not sure how I'm gonna do it, but we'll try and do it as best we can. So I know I kind of went through this one a little fast, but if you have any questions, feel free to comment below or use the Facebook group. I'm going to post all the code to my GitHub so you can download and play with it however you like. And yeah, stay tuned for the next one. See you guys.